Alright, so in calculus there's a lot of application units, and this is the first one. And this unit is the applications of differentiation, where you're going to be talking about what kind of things you can do with the knowledge that we got from last unit. And for the first video, I'm going to show you guys how you can use derivatives and tangent lines to be able to solve for, or not solve for, but approximate certain values that you wouldn't be able to do otherwise. So for example, you can use derivatives to find an approximation of the square root of 3 without using a calculator. Now, how could you do this? Well, what we're going to do is remember, once again, this is an approximation. We're not going to get the exact value. To find the exact value, you would need a calculator. But what we're going to do is we're going to turn this into a function. So the square root of 3, if we made a function like f of x equals square root of x, then f of 3 would equal the square root of 3, right? So the first step that we're going to do is we're going to turn what we're looking for into a general equation. And so, for example, in this case, square root of 3, then we'll just make the 3 an x, and we'll turn that into a square root equation where you could put any value and get a square root. That's not the point. We're looking for 3. Now I'm going to show you a picture that's going to explain why we're about to do what I'm about to do. Here is a plane, and here is the graph square root of x. Looks something like that. Now we do know, because we are smart students, that 1, 1 exists and 4, 2 exists, because the square root of 4 is 2, the square root of 1 is 1. But we're looking for this point, 3 up here. Whatever the y value is, that's the square root of 3, right? Because that's the coordinate. What we're going to actually do is we're going to use derivatives and tangent lines to get an approximation of this. We don't know what the square root of 3 is, we don't know what the square root of 2 is, but we know what the square root of 4 is, so why don't we use that to our knowledge. The square root of 4 right here is 2. There's a point right here at 4, 2. Now, if you took a tangent line of this and you drew it out, it would look something like that. And now if I went up 3 and put it on the tangent line, yes, that's a little off the line, but once again we're approximating. And basically I'm going to show you how you can find the 3 value of the tangent line and get an approximation of what the square root of 3 is. Okay, so I hope you understand that's why we're doing what we're about to do. So, we're going to first start off with finding the derivative of this, because we want to find what the tangent line at 4 is, because 4 is a close, nice square root that's near 3. So the derivative of f of x here is, well, this equals x to the 1/2. So it's going to be 1/2 times x to the negative 1/2, or we're just going to put an x down there. So that right there is the derivative of f of x. Now, to find the tangent line 4, we're going to need to know what the slope is at 4, and to do that, it's just f prime of 4 equals 1 over 2 root 4. And now I think you can see why we chose 4 is because we know what the square root of 4 is. And it's close to 3, so we get an approximation. You could do it with 1 too, but the approximation would not be as accurate because you're further away from the value you're looking for. So this right here would be 1/2 times 1 over 2, so it would be 1/4. Alright, and we already know our point, so we can make a point slope line here. So it'd be y minus 4, oh, I'm sorry, actually it's y minus 2 equals 1/4 x minus 4. Right? This is the tangent line at 4. So now all we gotta do is plug in 3 for x. So y minus 2 equals 1/4 3 minus 4. You'll end up with y equals, well, 3 minus 4 is negative 1 times 1/4 is negative 1/4. Negative 1/4 plus 2 is 1.75. So the square root of 3 is approximately 1.75. And if you had a calculator, you would see that this is actually pretty accurate.